So before the break, we talked about how to simplify, right? Using exponent laws. So one is multiplying, you add, pretty straightforward. Dividing, you subtract, but then just be careful if the denominator has more x, right? More exponent, higher exponent, then you need to have a 1 at the top, okay? So now look at the first simplifying questions. So of course you look at question A, right? To do this one, let me ask one of you, okay? Colin, how would you simplify question A?
Divide by 2.
Yeah, so you will get
4 over 5.
yeah, 4 over 5. Very easy, right? 4. Okay. But then there's actually things happening in between, right? In the equal, because right now you're very good at reducing. That's why you go straight to the answer 4 over 5. But we want to extend this idea, right? Or actually look closely at this so we can apply the same principle to expression that has variables, okay? So in fact, what happens in between, okay, between the 8 over 10 and 4 over 5 is this. You need to turn this, the 8, into factors, okay? So factors means they are separated by multiplying, right? Remember, factors, they are parts, right? So if I want to factor the 8, I can write it as 2 times 2 times 2, right? Those are called factors. I'll write it down, factors, right? And then the 10, I can factor into 2 times 5. So when the parts or the factors are the same, right? Top and bottom, they are the same, then they can divide each other. So it's gone, right? It's 1 on top and bottom. Okay, so after that, the leftover will become 4 over 5. Okay, so that's what actually happened if we do it very slowly, right? So only parts, we'll write it down, only same parts can reduce. And remember, if you want to see the parts, you need to put them into multiplying. Okay, so the most mistake happens when you cancel out the wrong parts. Okay, so when you are not supposed to cancel, because canceling is satisfying, right? You make it less and less, right? So sometimes you over cancel, over reduce, then that leads to a wrong answer. Okay, so let's look at question B, right? The one that has variable inside. So in the instruction, it will say simplify, right? And then write out the restrictions. So there are 2 parts to your answers. So first thing, okay, we'll start with simplifying. So to simplify, you need to factor, right? Turn them into parts. So this time when we simplify, not only we look at the denominator, we have to also factor the numerator. So this one is an easy one. It's already separated, right? -9 is one term, one part. 2, 3, 4, right? 4 parts. Denominator has 4 parts as well, right? They are separated by multiplying. So kind of try to compare with the 2 over 2, right? Compare left and right side. So we'll reduce the parts that are the same parts can reduce. For 9 and 6, we just reduce like you used to do, okay? So top and bottom, they can both be divided by 3, right? So we would have -3 over 2, okay? We'll do that part first. And then x to the 4 divided by x to the 1. So you subtract the exponent, so give you x to the 3. And y, they are the same exponent, so it's just canceled out each other, it's gone. And then z cubed over z squared, that will give you just z. okay? Or another way to write it is you can just write it as -3x to the cube because there's more x on the top. Z also has more on the top, right? And then 2 at the bottom alone, okay? So that will be our answer for simplifying, okay? All right, simplify. Okay, but then for restrictions, when you look for restriction, you cannot look at your simplified answer. You need to look at original. Okay, this one is to find restrictions. Because you need, your restriction is for the question, right? So you cannot ignore the part that you canceled out. Right, so you look at the original question, there are 4 parts, but then 6 you don't need to worry about. And then we just look at x, y, z. Okay, so x cannot be 0, y cannot be 0, z cannot be 0. So you just write it like that. So you get 2 parts for the answer. So this is the restrictions. Okay, do we have any questions so far? So this one is for simplifying, making one fraction and then reduce it, okay? So I'll let you try question A first and we'll check that answer. Okay, so raise your hand when you finish A. Okay, please raise your hand if you finished. Okay, Nathan, any trouble? Okay, Brendan, what's your answer look like?
2 over BC.
2 over BC. Okay, how about Nathan? What do you have?
Same as him.
Same as him. Okay, what's your restriction then, Nathan?
B and C aren't equal to 0.
How about A?
Oh, A, B, and C aren't equal to 0.
Yeah, okay, so all 3 of them. When you look for restriction, you have to look at the original questions, not the one that you simplify, okay? So 16 and 8, you can reduce into 2 on the top. A and A canceled out, right? B has more at the bottom, so you get 1 B extra. Same with C, 1 extra C at the bottom. So your answer will be this one and this one, okay? So remember in your homework, you have 2 parts. One is the simplified answer, the other one is the restrictions, okay? Now let's look at next one. Question C on the top. Okay, so first thing you need to see if you can cancel out the parts, right? So for the top, we have 2 parts. Okay, 2 parts, 12 and x. Parts are separated by multiplying. For the denominator, how many parts do you think we have here? Column, how many parts? What do you think?
4.
Okay, so you might think it's 4, so this is tricky part, right? Remember I said parts must be separated by multiplying, but then we have 1, 2, but then this is a subtraction. So you cannot say this is a part, okay? So because there's a subtraction between the terms here, so you have to connect them together, okay? So in fact, the denominator is only 1 part. Okay, if it's 4 parts, then it should look like this. 8 x squared negative 20 x, and they are all multiplying. If the denominator looks like this, then you are right, it's 4 parts. But because there's a subtraction or it could be an addition, then it connects everything together, counted as 1 part. Okay, so be careful with this, right? Because if you count the parts wrong, then we'll be canceling the wrong things. Okay, so only parts that are the same can reduce. So if you think that 8 and x, let me write it, okay? I think this is parts, right? Then you will be start to reduce like this, 8 and 12, right? And the x squared and x will start reducing. Okay, then that will yield the give you the wrong results. Okay, so the denominator right now only has 1 part. Right, count as 1 part, and parts can only cancel if they are the same, right? So right now nothing can cancel out because the top has nothing the same as the bottom. So what we need to do is to factor it. Okay, factor whenever you see that's possible. So when you see factor, you think about all the methods that you learned before. You have GCF, you have the grouping. We haven't forgot them all, right? Grouping. What comes after that? Brendan, what's after grouping? What did we learn?
Difference of squares, right?
Yeah, difference of square, very good. So formula. Okay, what else? Nathan? GCF grouping formula. Total 5.
I mean, like you could do substitution.
Yeah, substitution is the last one. What else are we missing?
Cross multiply.
Cross multiply, yeah, okay. For this chapter, mostly we'll be just using GCF. Okay, GCF, formula, and cross multiply. Okay, the easy ones. Okay, grouping and substitution is only in the factor chapter. Okay, so right now, right, if you look at the denominator, we can factor this. Right, 12x. What's the GCF here? Yosher? For the
4x.
denominator? Yeah, 4x.
Yeah.
Okay, very good. So we take out 4x, and then the leftover will be 2x minus 5. Okay, so now if you look at the parts again, how many parts in the denominator now? Nathan, how many parts in denominator?
There's 2 parts.
Which 2?
2 parts, Jason.
Yeah, which 2?
4x and 2x.
Okay,
4x and 2x take away 5.
Okay, there are actually 3 parts. Remember, parts must be separated by what?
Multiple, like the subtraction or sign.
No, multiplication. Parts are separated by multiplication. So 4x and 2x minus 5. Okay, 3 parts. And the numerator has 2 parts, 12 and x. Okay, you need to identify the right parts so you can reduce correctly. Okay, only parts that are the same, then they can reduce. They can cancel out. Okay, so now you identify the parts. The 12, right, and the 4 they can reduce, so make it into 3. Right, x and x canceled out. 2x minus 5, this part, it doesn't have the same parts on the top, so 2x minus 5 will stay at the bottom. Understand? Any questions? So this is our simplified answer. And don't forget what we need to write restrictions, right? So when you look at the restriction, look for restriction, you need to look at the question, but then the question is not very useful. It's not factored yet. So you need to look at this one, okay? Restrictions. Because remember, to find restriction before the break, you need to factor it first, okay? So you have the 4 and x and 2x minus 5. 4 is always constant, so don't worry about that, right? So let's, please write out the restrictions and raise your hand. Okay, one of the restriction. Sarah?
0.
0, very good. Okay, so coming from the x. And Brennan, what's the other restriction?
5/2.
Yeah, 5/2. Okay, so if the question can be factored, then you just focus on the factor one, right? Otherwise, from the original question, you cannot see the restriction. The previous question, we can look at the question because already factored, right? There are 4 parts in question B. So that's why we look at the original question. But then in question C, there's only 1 part, difficult to x, right? So that's why we factored it and then find the restriction, okay? So for your first step is to always factor if you see anything that's factorable, okay? So let me highlight. All right, so for this page, everything you need to factor first whenever possible, and then you start to do the canceling and then write out the restrictions. All right, so I'll let you try question 3 of them. Actually 4, okay? 4 questions. So question B, C, D, E. Okay, so these 4 questions, you please start with factoring. Even the numerator, you might need to factor if it's not already factored, okay? So for example, like question C, right? The top, how many terms on, how many parts on the top, Colin?
1.
Yeah, so now you know how to recognize, right? The numerator
One.
only has 1 part, so you not do any canceling at all, right? So you need to factor the numerator, factor the denominator, turn all into, okay, or factors. Parts are the same as factors. Okay, so I'll let you guys try it out. B, C, D, E. And you can raise your hand when you finish B and C, okay? Please raise your hand if you finish B and C. Don't forget restrictions. Has anyone finished B and C? Or anyone has questions? Okay, Brennan, what's your first step for question B?
I factored out 12bc cubed from the bottom.
Write it out. Okay, give me 1 sec. Okay, 12B. Okay, what's left?
2bc minus 3b squared.
2BC, but you took out BC, right? Can you double check?
Oh wait, yeah, sorry, 2c minus 3b squared.
Yeah, 2c minus 3b squared. Okay, and then the top is the same, right?
Yep.
Okay, okay, very good. And Aaron, what do you do after that?
You simplify by like crossing out, so the 4b squared and the c cubed, you can like simplify that.
Simplify. After you simplify it, what does it look like?
So in the end, you should get b over 3 multiplied by 2.
B over 3 multiplied by,
And the brackets are the same.
okay, 2c minus 3b squared. Okay, so 4 and the 12 you can reduce into 1 and 3, right? And then b and b squared can cancel out, right? Subtract the exponent. C cubed is completely gone, right? Because they're the same. Okay, so on the top is only b. The denominator is 3 and then brackets. There's not no parts on the top the same as the brackets at the bottom, right? Unless you have the same brackets top and bottom, then you cancel out the whole part. So you need to identify the parts correctly, okay? So nothing inside the bracket can be canceled out at all because it counts as one part. Okay, only parts can cancel out. Okay, now let's check restrictions. Okay, the restriction for question B. Colin, what's your restriction? Do you have it yet? Restriction for B.
Cannot equal 0.
Which one?
B and C cannot equal 0.
B and C cannot equal to 0. Anything else?
No.
Okay, are you sure? When you look for restrictions, you need to look at the line that has factored already, right? For example, like question C on the top, you don't look at the restriction, you don't look for restriction at the question, right? Because it's only one term, one part. You need to look at the restrictions after you factored, so you can identify how many parts there are. So what other restrictions? Or is that it? Only B, C cannot equal to 0. Okay, Nathan, what do you think? Can we find, do we need to
I
find
think it's-
more?
I think that's it.
That's it? Okay, you
That's
need
it.
to
Because
look at the
you
part.
can't put like you can't put like 3 in there.
Say that again.
I don't think you could put the 3 in there because 3 is like a constant.
Yeah, 3 is a constant, you cannot use that, right? When you look at the restriction, you need to look at this line. The one that you already factored. So like you said, the 3 is one part, right?
Yeah.
And then the B is a part, C is a part, but there's another part here. You need to get restriction from there as well.
Okay.
Okay, because that part is, right? Yeah, the restriction comes from all the parts. 3 is a constant, you cannot get restriction. B and C, we got it. From this part, we need to isolate. Isolate which letter, which variable should we isolate?
C.
You need to think about alphabet order. Which
B.
one comes first? Yeah, so you need to isolate B, okay? So when you get restrictions, you need to look at every part that has variable inside. Look at the denominator and look at each part. Whatever part that has variable, you can get restriction from it, okay? So isolate B. So what restriction would you have? You sure?
Plus or minus root 2c over 3.
Root 2c over 3. Okay, so the whole thing inside the root, right? Yeah. Okay. So square root 2c over 3. Right, does anyone have question about how we get the 3 restrictions? Move the minus 3b over, right? B squared. So 2c cannot be 3b squared. Divides both sides by 3. Right? And then you square root it. Square root both sides. And put plus minus. Okay? That's how you get this. So this is your answer. Okay? The simplified and the restriction together is your overall answer. Okay, let's look at question C now. Question C has numerator and denominator both factorable, right? So we need to factor it first. Whenever you get a question, first thing is to factor whenever possible. Okay, Aaron, have you factored it?
Yeah.
Okay, what do you have in numerator?
4x bracket 2x plus 1.
Okay, plus 1. And then denominator?
3x bracket 2x plus 1.
Okay, thank you. So now this one is easier to see, right? You have 1, 2, 3 parts. Okay, by multiplying. 1, 2, 3. 3 parts. And only same parts can reduce. So this one, the 2x plus 1, they are the same parts. They reduce each other. X and x cancel out each other. Okay, so your final answer for this is 4 over. Okay, restrictions. So Colin, can you try this one? What's the restriction for this one?
0 and negative 1 over 2.
Yeah, very good. Okay, so don't forget the part, even though it's gone, even though we canceled it out, but it's part of the question, right? So you need to include that. So x cannot be 0, x cannot be 1, negative 1 over 2, because you cannot use those two values and then sub it into the original question. It will make the denominator undefined, okay? Make the denominator 0, which makes the whole expression undefined. Okay, we got 2 more here, okay? So same thing, factor all the numerator and denominator and cancel out, reduce. Okay, raise your hand if you finish D and E. So I think C, D, E, pretty straightforward, okay? B deserve a star, okay? Pay attention when you get something like that. Because it has 2 variables inside the brackets, okay? So don't forget there's a restriction coming out from there too. All these should be factorable. Okay, let's check answer for D. Yosher, what are your factors?
X minus 2 and then x plus 5 and then
Mm-hmm. Yep.
x plus 3 and then plus 5.
Okay. X plus 3, X plus 5. All right, so the things that can cancel out. So now the top has 2 parts. The denominator also has 2 parts. Only same parts canceled out. So you got x plus 5 cancel x plus 5. We get x minus 2 over x plus 3, right? Pretty easy. What are the restrictions, Nathan?
The restrictions. It's just like x can't be like 2 or -3.
Where do you find restrictions? Numerator or denominator?
This denominator.
Okay, so which one?
When you find the restrictions, do you look at like, oh, this one?
Do you look at the question, or do you look at the part that you factored, or do you look at the reduced one? You have 1, 2, 3.
The
Which
one that you
do look
factored,
at?
number 2.
Number 2.
Number
Yeah.
2.
Yeah. Okay. So you will have 2 restrictions coming out from there.
Is it just like -3 and 2?
Hmm? You need to look at the denominator.
-3 and -5.
Yeah, -5. Okay. Numerator is the x minus 2. You only worry about denominator because you cannot have 0 in the denominator. So if you put -5 into the denominator, it will make the whole denominator become 0. And that's not a good thing, right? It will be undefined. All right, so that's your answer. Okay, look at question E now. Okay, Brennan, what are your factors for E?
Uh, 3x minus 2 and 2x minus 3. And the bottom ones are 4x plus 3 and 2x minus 3.
2x minus 3. Okay, let me double check. -4, -9, yeah. 6 and -12. Looks good. Okay, very good. So, Colin, what do you do now?
The 2x minus 3 cancels out.
Mm-hmm. So that's that.
And then
Right.
we get, yeah,
Okay, what's the restriction then?
-3 over 4.
Okay, x, don't forget to write x cannot equal. Okay, -3 over 4, is that it?
I think so.
Oh, which line do you look for restrictions? You have,
But do you look at the line? So is it 3 over 2 too?
yes, okay, don't forget, you have the original question, right? You have the factor part, you have the reduced part. You have to look at the one that's factored, okay? Look at this line. Those are the place you look for a restriction, the yellow highlighted, okay? The original question is difficult to find restriction because it's quadratic, right? It's difficult to solve for x. So that's why we look at the one that's factored. So if you highlight it, okay, then you can remember where to look for it. Okay, so that's our answer for those two. Okay, last thing is question D on the top, okay? Well, question D is not really too bad. Okay, we'll look at D. D is also factoring, okay? Except the denominator, we had to factor it differently. Numerator, what's the GCF? Yosher?
2z.
2z, okay, so 2z. So left with 4 plus 3z. Okay, to factor the denominator, Brandon, how do we do that?
Difference of squares.
Yeah, difference is squared, so turns into what?
It's 3z minus 4 and 3z plus 4.
Yeah, perfect. Okay, 3z plus 4. So the parts that are the same is this one, right? 4 plus 3z, 3z plus 4, they are the same part. Remember the z, this part cannot cancel out with that, okay? That's not correct because it has, when you cancel, it has to be the whole parts canceled out. So the leftover is only 2z and 3z minus 4. Restrictions. Okay, Nathan, where do we find restriction again?
Like the second one, like the one you sort of like this. Yeah.
So what is it?
Hold on.
Okay. Let me
Like
highlight.
4/3.
Yeah. 4/3.
Yeah.
Anything
And
else?
then -4/3.
Yeah, negative 4.
-4/3.
Okay, very good. So the yellow highlighted is where you get the restrictions on. Okay, I think is if I highlight it, it's easier to remember. Okay, so this part, right, for question A, this part, okay, all those are the place you find restriction. Okay, question F is a little bit different because it has two variables, but still the same thing. Same idea, you factor like before and find the parts that are the same, then reduce it. And when you get the restrictions, you isolate the in order of alphabet, right? So X and Y, you isolate X, all right? So last question we're gonna do for today, okay? So if you finish last one, you can raise your hand. Oh, everyone already done, huh? So fast. Okay, Brandon too. So factor first. And then cancel out the same parts. And then write the restriction now. Only 3 people finished. Any more? Let me know if you have trouble. 4 people now. Okay, Nathan, have you factored the numerator? Okay, Nathan, can you give us your factor for the numerator?
I think I got it wrong because I only did the bottom, so I'm gonna have to try to redo it.
Which side you have factored, top or bottom?
I just did the whole thing wrong because I didn't realize that the top was the same as well.
Oh, you didn't get anything the same?
Yeah, so I did it wrong. So I'm gonna try to redo it.
Okay. Okay, let me know when you got the factors for the numerator, okay, Nathan?
Yep.
The numerator, you use the cross factor, okay? It has 3 terms and there's no GCF, so use cross factor. And let's get the denominator from someone else. Aaron, what's your denominator look like?
3x multiplied by x plus y.
X plus y, okay? So that's the denominator. And let's just wait for the numerator.
Five x take away 2y brackets and then x plus y.
5x take away 2y and then x plus y, like that?
Yeah.
Okay, let me see. So minus 2 plus 5. Yeah, looks good. Very good. Okay, so the parts that is the same, that is the same as these two. Right? Pretty easy. So your leftover is 5x minus 2y over 3x. So remember, do not cancel over canceling, okay? Do not start to cancel, okay, I like to cancel, so let's cancel the x and x, okay? Please don't do that for your homework, okay? Only cancel the parts that are the same. Last thing, restrictions, okay? Sarah, what's the restrictions?
0,
Yeah, anything else?
negative y.
Yes, and negative y, okay? You get 2 restrictions. You look at the denominator, that's factored, okay? So if you have any more questions about correction or today's lesson, you can stay after class. And I'll see you next week, okay? No class next week, okay?
Okay.
Bye-bye.
Thank you, Jason.
Yeah, you're welcome.
Bye.
Bye-bye.
Bye.
Bye.